Hi, and welcome to one of the last of our functions videos, logarithmic functions. By this point in time, you've gotten a few functions under your belt, and now we should be really flying through this. So our format is a being a coefficient or a number in front, multiplied by the log x. And this here is representing log to the base 10 of x. You're going to see something in the videos that says ln x. And what that is log to the base e. So this is normally a log to the base 10. And that's the same thing that you would see on your calculator. Log to the base e is the natural number. So when you see ln, that is the same as log. It's just a special kind of log. And so when we graph these functions, we want to graph them, with a bracket around the x. That's sort of the way to kind of get it into the computer. So it doesn't matter which one you use, metacalculator or Desmos. You want to put a bracket around the x. And so if you're seeing something like this, we're looking for the x-intercept. We don't have a vertex here. There's no high point or low point because this is continuing on forever in this increasing direction and then decreasing direction. So the x-intercept is going to cross here at 1 and 0. The y-intercept, we see this coming down, and you can zoom out, but you'll find that this hugs this y-axis, so there's none for the y-intercept of a logarithmic function. For domain, we're looking at what x values produce y values, and if you put in a negative number, you'll get undefined. Your calculator will spit out error, because nothing can possibly come out. So this is saying x, in order to get something out, x has to be greater than 0. Make sure you don't write that line underneath. It has to be greater than 0, but not equal to 0, because we don't have a y-intercept. The range, so what y values can come out, and every possible number can. We can have a 10. We can have a minus 10. So y is in the set of all real numbers. If we look at the end behavior and we go from left to right, we're going to meet this function first here in 4. So from left to right, beep, beep, we meet it here in 4, and we're going to leave it in 1. And is this an increasing function or a decreasing function? And we would say that as x gets bigger, y gets bigger. So this would be an increasing function. So this function here, we know whether it's increasing or decreasing because a is positive or greater than 0. So this could be 3 log x. This could be 3 log x. If we look at the other sample, we see the same x-intercept, strangely enough. We see that crossing at 1, 0. We see that there's no y-intercept at all. The domain, x is still greater than 0. The range, y is in the set of all real numbers. End behavior here for this one is a little different because as we come here, we meet it up in quadrant 1. And we leave it in quadrant 4. And lastly, increasing or decreasing function. As x increases, y seems to be getting smaller. It gets more negative, so that'll be decreasing. So an example of a logarithmic function in sort of everyday life, we've got pH scale, we've got the decibels for sound. The decibel is a logarithmic scale as well. So we do see these kind of functions in our everyday scenarios.